Okay, so from a sofa somewhere in Prague, we continue. 17.25 was the average. Normally I advise do a stoichiometry last because it's sometimes it can be quite dispiriting, but this was the easiest question on the paper. Just balance the equation, add up the coefficients. I see sodium appears just in one molecule on each side, so I'm going to do that one first. I'm going to put a coefficient of 2 there. Now the chlorines are out of balance, so I'll fix the chlorines. That's it. Yep, everything else is good. So let me add up the coefficients. 1 plus 2 plus 1 plus 1. So it's going to be 8. So 1 is C. Nice. Question 2, for these kind of questions, you've got to decide first of all, is it going to be a big number or a small number? So the number of oxygen atoms in 2 moles of this thing, well, the molar mass of this is going to be like 250. So 2 moles of this is going to be like half a kilogram of these crystals. So that's going to be a lot of oxygen atoms. Oxygen atoms are really small. So it has to be C or D. Okay? So I know if I've got 1 mole, then I would have 6 times 10 to the 23 of these molecules. But the question tells me there's 2 moles. Okay. So I'm going to have 12 times 10 to the 23 of these molecules. Now what about the oxygen atoms? How many oxygen atoms do I have per molecule? Well, I've got 1, 2, 3, and then I've got 10 in that hydrated bit. So in total I have 13 oxygen atoms. So what I'm going to do, I know I've got 12 times 10 to the 23 molecules. And I've got 13 oxygen atoms per molecule. So now the answer is going to be whatever that is. That's 12 times 13 times 10 to the 23. What's 12 times 13? 12 is 144, and another one, 144, 154. So it's 156. So 156 times 10 to the 23. Fix those decimal places. 1.56 times 10 to the 25. Oh, bit of dirty rounding there, but I think it's D. I think 2 is D. Next one. So for the initial solution, they're giving me the volume and the mass and the type of molecule. So the only calculation I can really do there is concentration. So I'll do that. So concentration of the initial solution is moles over volume. And to work out the moles, well, that's going to be the mass over the molar mass over the volume. So it's 1.42 divided by 142 divided by, well, the volume is 100 centimeters cubed, but you've got to be in decimeters cubed, so that's going to be 0.1. 100 centimeters cubed is 0.1 decimeters cubed. So that gives me 0.01 divided by 0.1. Oh, let me just be careful, that's 10 to the minus 2 divided by 10 to the minus 1. If I divide, I subtract, so that's minus 2 minus. Okay, so that's going to be 0.1. So my initial concentration is 0.1 moles per decimeters cubed. But I've got to dilute it to 0.02. Okay, so the equation that you use is C1V1 is C2V2. That's used for dilutions. Initial concentration times initial volume is final concentration times final volume. So my initial concentration is 0.1, and my initial volume is 0.1. My final concentration is in the question, 0.02, and that leaves me with V2 as my unknown. So 0.1 times 0.1 over 0.02, that's going to be 0.01 over 0.02. That's just a half, isn't it? That's a half. So V2 is going to be half a decimeters cubed, which is C. So 3 is C. Yeah, leave the stoichiometry ones to the end. That was more than a minute and a half. Question 4. 73% of people got this right. I'm going to draw out the boxes. I like that. So I've got moles is mass over molar mass. I can't help myself, I'm going to balance that equation. So for percent yield, that's going to be my experimental value over my theoretical value multiplied by 100. So according to the question, I made 2 grams of ethene. So 2 grams of ethene is going to be 2 over 28 moles of ethene. Moles is mass over molar mass. Where did I get the 28 from? There it is. So that's my moles of ethene experimentally. Well, how much was I going to get theoretically? So I think T for table, T for theory. The question tells me that I have 5 grams of ethanol, which means I have 5 over 46 moles of ethanol. And since the molar ratio is 1 to 1, I've also got 5 over 46. Missed my motorbike. 5 over 46 moles of ethene. So my theoretical value for the moles of ethene was 5 over 46. Multiply that by 100, and see which one's the answer. That's going to be B. There we go. This is the second time I did this. I got it right, but I did it the long-winded way. I was doing the mass calculation, which gives the same answer, but it's just easier to do the moles calculation. The next question was the most difficult one, and that's confusing initially because that's a grade 8 question. The problem people had was they gave the answer for the atom, and the question was for the nucleus. Perhaps they should have bolded that in hindsight. Okay, so what's the atomic number for magnesium? Magnesium has an atomic number at 12. That's going to give me the information I need for the nucleus there. So the atomic number is the number of protons in a nucleus, 12. And the difference is the number of neutrons. So that's going to be 14. And there are no electrons in the nucleus. Chemistry, they orbit the nucleus. So 12 protons, 14 electrons, that's going to be D. 5 is D. It's the second least discriminating question. That meant that the smarty pants and the people who don't know what they're doing didn't really distinguish between them. It was done equally poorly. The most discriminating question was question 6, line spectra. I do like line spectra. All right, so I think big jump, big energy. So any big jumps, the bigger the jump, the bigger the energy. And the question isn't asking about energy, it's asking about longest wavelength. So if something with a long wavelength has low energy. So if we're looking for the longest wavelength, then we want the smallest jump, because big jump is short wavelength. And they're asking about longest wavelength. So we're looking for small jumps. And if it's emitting energy, that means it's going to be going down. As they go from a higher, the electrons go from a higher to a lower energy level, they emit energy. So the smallest jump down, that is A, 6A. Yep, 6 is A. That's the smallest jump down. What increases across the periodic table from left to right? Well, I think the easy one for me to do is electronegativity. I see that as one of the answers there. So I know that fluorine has the highest electronegativity. So as you go across the table, it increases from left to right. So electronegativity is good. What about the one here? What about neon? Well, that doesn't really have an electronegativity value, so we exclude that. So electronegativity, what else increases as we go across? Well, as you cross the periodic table, they get smaller, the atoms, don't they? They're bigger here, and then smaller, 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 smaller. So atomic radius is wrong. So that means B and C is wrong. Why do the atoms get smaller as you cross the periodic table? More electrons, more protons, more electrostatic attraction, and the electrons are added to the same shell. That's the 2-point answer, in short answer. So I've got A or D. Ionic radius is a tricky beast, so it's probably not that one, because there are different ions. So my instinct is 7D. Is that right? Yeah, 7's D. So let's think a bit more about it. The first ionization energy, that's how easy is it? How much energy does it take to rip off one valence electron? Well, the valence electron on, for example, lithium, that's really easy to pull off compared to the others in that row, because the electron's furthest from the pull of the nucleus. The electron for fluorine, well, that's a teeny weeny atom. That electron's closest to the pull of the nucleus. So electrons are negative, the nucleus is positive. If it's really close in fluorine, you're going to need a lot of energy to pull it off. It's a high first ionization energy. So it's D. Which element's in the P block? So the P block is, are these ones here? That's the P block. What about this guy? No, that's 1s2. That's in the S block, isn't it? Well, let's just peck around, see what we can find. Lead. That's the first one. So 8 is A. Yep. 8 is A. Even the Romans knew that lead is something you shouldn't drink. So all of the troubles we're having with the lead pipes and the lead in petrol, 2,000 years ago, they knew that was a problem. Question 9. Magnesium nitride. Okay, so I know magnesium is Mg and nitride is nitrogen. So let's go back up to the periodic table. So magnesium wants to lose 2 electrons because it has 12 electrons, and if it loses 2, it would have 10, just like neon. Remember that pretty much all elements want to gain or lose electrons to get the same number of electrons as the noble gas, as the nearest noble gas. So magnesium wants to be 2+, and nitrogen, well, that's got 7 electrons, 1 more, 2 more, needs 3 more. So nitrogen needs 3 more electrons to be stable. So magnesium wants to lose 2 to become magnesium 2+. Nitrogen wants to gain 3, and you just use the crisscross method. Mg3N2. D. 9 is D. The longest carbon to oxygen bond length? Well, so the longest carbon to oxygen bond length will be the single bond. Single bonds are the longest. So we're looking for probably the single bond here. Well, carbon monoxide, I know that that's got a triple bond. If I draw the Lewis structure out, so that's actually going to be the shortest. That's wrong. For methanol, I know that for methanol, it is a single bond, so I'm almost certain it's that one. It's B. 10B, yep. For completeness, let's carry on. The bond here for the ethanoate ion is actually not a double bond, not a single bond. It's a 1.5 bond. There's some resonance going on there with that cheeky double bond to single bond jumping. And for methanal, yes, if you ever encounter a lot of methanal, it was the worst day in your life, because that's the preservative fluid they put in dead bodies. That is a double bond. So the answer is 10B. That's okay. The least discriminating. It's a negative discrimination. The smarter you are at chemistry, the worse you did. But how do they know how smart you are? How do they know how smart you are at chemistry? You're doing a chemistry exam, aren't you? Once you're finished, they check to see how smart you are. Okay, so there's a trick within a trick. So I haven't seen this question for years. Let's see if I can get it right. What's the predicted electron domain geometry around the carbon? That's the trick. Is they're not asking for the shape, they're asking for the electron domain geometry. They're asking for the shape of the electrons, not for the shape of the molecule. That'll get you. All right then. So we draw out that molecule. It looks like there's a carbon, double bond, oxygen, and there's some weird nitrogeny stuff going on up there. I suppose you could draw it out using the regular Lewis structure method, add up the valence electrons, la-di-da-di-da. I'm going to do it that way. Okay. Every atom has 4 lines. Remember, each line is an electron pair, stable octet, and hydrogen just has 1. So the carbon atom, the electron domains for the carbon atom, there's 3 of them. 1, 2, 3. Well, what's an electron domain? Single bond, double bond, triple bond, lone pair. That's an electron domain. So that's going to be trigonal planar. And what about for the nitrogens? Well, the nitrogens have a tetrahedral arrangement. Now, we're not looking at NCHH. I know what you're thinking. That's not tetrahedral Thornley. That's trigonal base pyramid. The question is asking about the electron domain geometry. The electron domain geometry for the nitrogen is tetrahedral because there's 1, 2, 3, 4 pairs of electrons. So trigonal planar and tetrahedral. B, 11B. I'm not sure I would have noticed that unless I saw in the examiner's report that it was reverse discrimination. 12. So increasing boiling point. So higher and higher and higher boiling point. Oh, you've got to look at the intermolecular forces, haven't you? That governs boiling point. I can see, what's the strongest intermolecular force? It's hydrogen bonding. So I can see the potential for hydrogen bonding in this molecule between one of those and another molecule. I can see the potential for hydrogen bonding in that molecule. Again, I'm not highlighting, that isn't the hydrogen bond. That's a covalent bond. That's an intramolecular attraction. Hydrogen bonds are between one molecule and another one. So I know that this doesn't have any hydrogen bonds. A molecule can form hydrogen bonds if it has an F to H bond in it somewhere, O to H or N to H, recall. So I know that that's going to be the weakest one. The lowest intermolecular, this is going to be this one first. Is that enough? No. So I've narrowed it down to C or D. A and B must be wrong because the middle molecule does not come first. All right then, and so I guess you're just concerned about these two functional groups. The carboxylic acid group, which is this one, is that giving it a higher or a lower intermolecular force than, why did I do that? Than just this alcohol group here. And you just have to pretty much remember that carboxylic acids have higher melting and boiling points than alcohols. The reason why, well, there's an extra oxygen there, and oxygen has more electrons than the hydrogen that you were expecting to be there, so more electrons, more London dispersion forces. So the acid should be at the end, which is D, 12D. Yeah. Carboxylic acids have higher boiling points than alcohols. Second easiest. I'm not even drawn the line. Well, that to me looks like an endothermic one. The products have higher energy than the reactants. So that's going to be A or B. The products have a higher enthalpy than the reactants. Yeah, so that's A. So 13 is A. It's higher energy. This has higher energy. How do I know? Well, because this axis literally is energy. And it's literally higher up on that axis. Second easiest. Second most difficult. I think I've seen the trick in this one. I was just going to do it and probably get it wrong, but knowing it's the second most difficult, they're asking for the enthalpy change of combustion of the urea. Enthalpy change of combustion is completely combusting 1 mole of the chemical. There's 2 here. So whatever I do, at the end, I have to remember to halve the answer because of that 2, that coefficient of a 2. I bet that's it. Yes. So it's going to be B or D because I can see that there's a half there. So it's just products minus reactants when it comes to delta HF. So I see delta HF, it's just products minus reactants. So so that means minus 394 is for carbon dioxide. And so that minus 394 has to stay there because that's the product minus reactant. So where do I find minus 394? Both B and D have that. Okay, not forgetting to double that. Not forgetting to double that. Okay, let me try with the urea. The urea is minus 333. Products minus reactants. So that there should be a plus 333 in the answer. And so the plus 333 is in B. So I think 14 is B. Yes, that's some seat of the pants stuff there. Is this SL? Yeah, okay. Question 15. I do like these questions. I'm not entirely convinced how I could teach them, but I do like these questions. So enthalpy change of neutralization. So I'm going to have delta H is, well, I know there's going to be a minus there because acid and base react and have an increase in temperature. But there's no minus in any of the answers. But maybe a minus will come out with the algebra, I don't know. Anyway, and so it's MC delta T over the moles of choose one of the things that's doing the heating. Up to you. There's the same amount of moles of each one. So N is the mass of what's being heated. So I've got 100 centimeters cubed and 100 centimeters cubed. So that's going to be 200 centimeters cubed, but I'm going to put 200 grams. Why am I going to put 200 grams? Well, because it tells me that 1 centimeters cubed is 1 gram. Is that enough for the answer? Well, I can exclude C. So C's done. Because for C, they didn't have the mass of everything that got heated. The specific heat capacity is 4.18. So that should be at the top. top of everything, so that's not going to help. And the temperature change is Y, which should be at the top. Now for D, that's wrong. If you're doing the change in temperature, you don't have to add the 273. That's like a red herring there. So fast forward if you understand why D is wrong. So for D, they're adding 273, and you didn't need to do that. For a temperature change, you don't need to add the 273, and let me try to explain why. You could go from 0 degrees centigrade to 27 degrees centigrade, and that's a temperature increase of 27 degrees centigrade. What about in Kelvin? They're supposed to be Kelvin, isn't it, all this chemistry? Well, that gives me 273 Kelvin turns to 300 Kelvin. The temperature increase is still 27, except it's Kelvin this time. So since we're looking at the temperature increase, you don't need to add 273 onto that 27. That's how maths works. Okay, back again. So moles at the bottom is the moles of the fuel. It doesn't matter which one you choose, because they're the same in this case. So moles of fuel is concentration times volume. So the concentration, we'll choose sodium hydroxide, it doesn't matter, times volume, and the volume is 100 centimeters cubed. So that's 0.1 decimeters cubed. Is my answer there? Well, it can't be A, because A has a 2 at the bottom, so it must be B. Yep. So the answer is B. 16. Oof, that's a dog's breakfast of a diagram there, isn't it? The activation energy of the reverse reaction. So activation energy is how high is the bump you have to get over for these diagrams. So for the reverse reaction, if I'm going back this way, how high is the bump? From Z to X plus Y. God, I'm going to have a stroke trying to work this out. Okay, so it's how high is this hill? Activation energy is the hill. So whatever that is the answer. It's D, 16C. Damn it! It's the first one I got wrong. Oh, I thought it was going to be 100%. Let me read the question again. With a catalyst. Damn it. So, with a catalyst is the lower energy one. Of course. Oh. So it's going to be this height. C. Darn it. 17. Which factors affect the rate of reaction? Well, we're looking at collision theory. Anything that changes the frequency of collisions, the geometry of the collisions, or the energy of the collisions is going to affect the rate of reaction. So particle size, yep. If you powder something up, you increase the surface area. So 1's correct. So looking at A, B, C, D. C's out. Concentration, yep. You increase the concentration, there's more collisions per unit time. So 2's correct. The pressure of reacting gases, yeah, if you change the pressure, if you increase the pressure, then there's going to be more collisions per unit time. So they're all correct. So that's going to be 17D. Yep. 18, what doesn't affect the position of equilibrium? Without looking at the question, I would say it's catalyst. Yeah, C. 18 is C. Oh, how do you get that, Thornby? Okay, so there's different numbers of gases on each side. 2 on that side and 1 on that side. So if you change the pressure, it's going to shift the position of the equilibrium. If you increase the pressure, it's going to shift to the side with the least gas particles. Temperature, if you increase the temperature, it's going to favour the endothermic side. You change the pressure. If you change the volume, well, if you change the volume, you're going to be changing the pressure, aren't you? As you make the container smaller or bigger. So catalyst. Catalyst speeds up the forward and reverse reaction equally. I'm still upset about 17. 19. Activity series. Don't often ask about this. Which react with dilute sulfuric acid? Okay, so I don't think this is part of the course. It's not specifically part of the course, but here's how to do it. There's hydrogen. Acids have H plus in them, don't they? So these here probably don't react with acids. These metals, on the balance of probability, don't react with acids. But these metals do react with acids. And that cutoff is hydrogen. It's more complicated than that. Oh, you're so smart for me. What it is, but that's what we're going to do. So does copper react with acid? No, it doesn't. Because it's on this side. Copper oxide, well, yes, it does. Copper oxide does. And copper carbonate does. Both of those do. So the answer is going to be C, 19C. There are 5 reactions that you have to know for acids and bases. So an acid plus a hydroxide, an acid plus an oxide, an acid plus a reactive metal, acid plus hydrogen carbonate, acid plus carbonate. 2 of those are there. 20. Which statement is correct? A strong acid is a good proton donor? Yes. So a strong acid has a weak conjugate base, and a weak acid has a strong conjugate base. The theory's tricky. Just remember that. So it's C, isn't it? 20C? Yeah. Strong acid has a weak conjugate base. 21. Same oxidation state in both species. I would start with the easiest one, which is elements have an oxidation state of 0. That doesn't help me at all. I can see it. I'm looking for the trick ones. The tricky ones for IB are H2O2. You're expecting oxygen to be -2, but in this case, oxygen's -1. And for something like aluminium hydride, you're expecting hydrogen to be +1 in a compound. It's -1 with a metal. So I'm looking at this here. Oh, and that one down there. So one of those, both of those tricks are there. Same oxidation number in both species. Okay, I'm just going to go through them. So that's going to be +1, -2, +4, -2, +1, -1, +1, -2. +6, -2, +6, -2. There we go. So it's that one. 21C. Yep. 21C. Oxidation. Well, there's 3 definitions of oxidation. Oxidation's adding oxygen, removing hydrogen, or an increase in oxidation state. A. That's 22A. Definition question. 23, electrolysis of molten zinc bromide. So you're an SL, so electrolysis just makes the elements. If you electrolyze platinum iodide, you're going to make platinum and iodine. If you electrolyze zinc bromide, you're going to make zinc and bromine. So it has to be A or C. You just have to work out which goes to which. Well, if it's zinc bromide, I'm going to have zinc 2+ ions, and I'm going to have bromide ions, 2 of those. So the zinc 2+ ion is going to go to the negative electrode, isn't it? By electrostatic attraction. So zinc goes to the negative electrode, so it's 23A. 23A. 24. The same homologous series. Oh, my brain's hurting. Well, let's have a look. A, B, C, D. So B's wrong because B has an alcohol and an ether. An alcohol and an ether. It has this functional group and that functional group. So that ain't right. D's wrong because D has a ketone. It has a ketone and an ether. They don't often ask about ethers. So that's wrong. C has an alkene, if you draw it out, and an alkane. So that's wrong. So I think by default it has to be A. 24A? Yes. 24A. So what functional group is that then? Is that a triple bond? Oh, it could be. Yeah, triple bond. Alkynes. 25? What compound is this? Ooh. So it's a carboxylic acid. How do you know? You just have to learn it, don't you? So it's going to be a carboxylic acid. Well, that doesn't help. What's the longest chain? That's the backbone part of the name. I can see a chain here of 4. So that's going to be butanoic acid. Here's something I learned about butanoic acid from a podcast, from a book I just read. British people hate American chocolate. It tastes like baby sick and candles to me. The reason is because the way the Americans make their chocolate is there's a little bit of butanoic acid produced when they kind of mess about with the milk. Now butanoic acid is the flavour of Parmesan cheese and smelly shoes. So a little bit of that to me tastes awful in chocolate, but if you've been raised like that, you'll like it. The Europeans call British chocolate vegeler because there's so little cocoa in it. So I'm taking no high ground on the chocolate front here. And so I'm going to name it. You start from the functional group here. So it's 1, 2, 3, 4. So it's going to be 3-methyl, 3-methyl, butanoic acid. 3-methyl butanoic acid, 25D, yeah. It's not always obvious that you have to number from the kind of big functional group. A couple of years I forgot to teach that when I first started teaching. But that's where you start from. Second most discriminating, right? Switch on an extra brain cell so I don't fall for the trap. What's the mechanism for the reaction of propene with iodine in the dark? Sounds like a 90s rock song. I think that's addition, isn't it? Because the only SL reactions you need to know are addition. There's 5 of them. You're going to add hydrogen and a halogen, water, and polymerization. So it's addition. Hopefully that's enough. Yeah, electrophilic addition. Addition's good enough. Is that right? 26A, 26A. Still angry that I got one wrong. That's going to be perfect. 27. Structural isomers. So same formula, different structure. What are structural isomers? What do I count here? I count 2 carbons, 6 hydrogens, 1 oxygen. 2 carbons, 6 hydrogen, 1 oxygen. Yep. 2 carbons, 6 hydrogens, 1 oxygen. 2 carbons, 6 hydrogens, 1 oxygen. But hold on, isn't that just... So that doesn't count. Same formula, same structure. That's not an isomer, that's just, it's the same. So 1's right, 2's wrong. Is that enough? 1's right, 2's wrong. B, 27B. Yep. At the bottom one, they're also isomers. 28. Infrared, well, let's start from the beginning. H1 NMR looks at hydrogen environments and the number of hydrogens in that environment. Mass spectrometry, that's you'll have one snip on the molecule, don't snip off a hydrogen, and then it breaks it into two and it weighs those fragments. And infrared, well, that just looks for what bond you've got. Is it a CH or a CO or an IBR? What bond is present? The bond's present, 28B. "29, on the IB Facebook group for chemistry teachers, every year the first questions are, I'm uncertain about uncertainties. Yeah, we all hate them. The IB's backed off a lot. It used to be a lot worse. You could lose a lot of points if you couldn't do it. But are they still important? So if I multiply two quantities together, what happens to the uncertainties? Well, let's take a 10 plus or minus 1 multiplied by 20 plus or minus 2. So that's going to be 200. Now what would I do with those uncertainties? Well, this is a 10% uncertainty, and that's also a 10% uncertainty. So the actual uncertainty was plus or minus 20%. So what I've done is I've summed the percentage uncertainties and put it there. So which answers that? Percent uncertainties are added. D. 29 is D. 30 is about graphs and variables. Well, I have to think about this. The independent variable, the one you change, is down at the bottom there, isn't it? And then the dependent variable, what you measure, is on the y-axis. So dependent variables on the y-axis, independence on the x. So it has to be either B or C. And what is it I'm changing? What is my independent variable? It's the temperature. It's changing the temperature, seeing how fast the reaction goes. So temperature and independence, so that's C. And we're done. 29 out of 30. Yeah, it's still 7.